Well, as we calculate the limit, many times that we have this type of limits. 0 to the power of 0. That means this one goes to 0, and this one goes to 0. See, like these limits, this limit, this kind of limit. See, 0, 0, 0, 0, 0, 0, 0. See, these limits all are that type of limit calculation. So I would like to come up a method which is very nice to deal with these kind of limits. So okay, now we have to know something before something, right? So before discussing these limits, let's have some basic limit I think we should know. First is that this limit, sine x over x, now as a limit x goes to 0. This limit. Now we learn it in finding derivative of sine x, therefore we don't use L'Hopital's rule, right? How to prove this, how to get this limit? We use a unicircle. A circle of radius 1. Radius 1. So therefore, if this angle is x, the arc length is x. See, this arc length is x in radian, of course. And this is sine x. And this is a tangent x. So therefore, x is between tangent x and the sine x. All right, this is sine x, this is tangent x. Now, and then we divide it by sine x, we get a 1 x sine x. This is sine x over cosine. Divided by sine becomes the 1 over cosine. As x approaches to 0, this one approaches to 0. This is 1. Therefore, x over sine x is squeezed into 1. See, that is the way to prove that this limit is 1. Yeah. Okay, then second thing is that we consider this limit as x approaches to 1, x approaches 0, is the basic formula. So we are looking for this limit. So this limit is equal to the limit x goes to 0, x to x. We calculate y. We take log y, right, is equal to the limit x goes to 0, x log x. Then we use the L'Hopital's rule that this one is equal to the limit x goes to 0, log x 1 over x, right? Then we take the limit after the derivative. This is 1 of x, this is 1 of x squared. So this one is equal to, after cancel x equal to 0. Therefore y is equal to 1, right? In other words, this limit is 1. Now what I want to say is here that we consider this limit is a basic formula, that is 1. That means this limit is equal to 1. Okay. Yeah. X from right hand. Okay. So this limit, we use this limit to calculate all these others. Okay. So I consider this limit is basic. Now let me do it one by one. Okay. Let me do one. Say this one. the limit x goes to 0, sine x to the power of x. Now, I consider this is my basic formula, right? So this one is equal to the limit x goes to 0, x times x sine x to the power of x, right? So this one is equal to the limit x goes to 0, x to the x multiplied by, this is a 1, right? As x goes to 0, this is a 1. So times 1, right? And this one is considered as a basic formula. So this is the 1, you see? In other words, what I want to say is that we are calculating these limits by using this as a basic formula. We can have the result easily, no? Let me do one after the other. Let me do this one, okay? Now, tangent to x. Let me forget to write limit the formal way, okay? This one is equal to sine x, right? Sine x to the x multiplied by 1 over cosine x to the power of x, right? Now, I omit writing the limit. Okay, this one, as I did in this way, okay? I don't repeat. This is equal to 1. And this one is equal to 1. So the result is equal to 1. Okay, now, this one. Square root to the power of x. This one is equal to this one equal to x to the half, right? To the power of x. I omit writing limit. Okay, excuse me, because this is not necessary. Well, just to save time. So this one is equal to x to the x to the power of x, right? So this is the basic formula is 1. So the result is 1. In other words, we calculate the limit very easily by knowing that this limit is 1. Now, next one, sine 2x. Sine 2x to the power of x. Now, these kind of limits many times while we meet those, we have these limits, you know. As we know this basic limit, we can find the others very easily. That's what I meant. So this one is equal to 2, right? Sine x, cosine x to the power of x. This one is equal to 2x, and the cosine x, right? And the sine x. Okay, this is 0. This goes to 0 is 1. This goes to 0 is 1. This goes to 0 is 1. So this is equal to 1, see? Alright? I don't write the limit because, you know, I just want to save time. Now, next one, tangent to x. Tangent to x to the power of x as x approaches to 0. Find the limit. Now, this one is equal to, well, quite obvious that this is sine 2x to the power of x times 1 over cosine 2x to the power of x, right? Take limit. I just omit writing limit. And this one, as I did, see equal to 1, right? So whole thing equal to 1. This limit equal to 1, as it did. This limit equal to 1. Now, next one, cube root of x to the power of x. as x approaches to 0, we want to find a limit. Now this one is equal to x 1/3, right, times x, the power of x equal to x to the power of x times to the cube root. So this one is 1, so this is equal to 1. See? Okay, next, what else left over here? Let me see. This x to the sine x. X to the sine x. Well, I write this way, right? I write to the sine x and x to the sine x to the sine x. Alright, this one equal to sine x to the power of sine x. And this one as x goes to 0 is a 1. Therefore, 1 to the sine x, 1 to 0, see, that's 1 to sine x, right? So equal to 1. So this one we have done it, it's equal to 1. This is equal to 1. Now, 10 to the tangent, x to the tangent x, while we write tangent x and x over tangent x to the power of x, right? Now, this one is equal to tangent x, sorry. Tangent x to the tangent x times, this is sine over cosine, right? To the tangent. And this one, as we have done, that's equal to 1, basic formula. This limit as x approaches to 0 is 1. Therefore, this is 1 to the power 0 is 1. So it's equal to 1. You know, what I meant that by knowing this basic formula, all these limits could be very easily done. And what else? How about this one? X to the power of x. X to the square root. Okay, that's the one. And this one equal to x square root times x square root squared, right? So this one equals square root times x square root to x square root. So this is 1 times 1 equal to 1. See, by doing this basic formula, everything can be done easily. So what I discussed that this type of limit, this type of limits can be calculated easily if you know this limit is 0. This limit is 1. Then you can know the others very easily. Okay, I hope you like this video. Thank you.